Okay, so we have a few things left that we're going to talk about in terms of geometry. The next one we're going to look at is something called this Pythagorean Theorem. We're going to need square roots in order to be able to do this. So before we get to Pythagorean Theorem, let's talk about square roots. Square roots, this is the opposite of squaring a number. When determining a square root, ask yourself what times itself gives you the inside number. We have the symbol for square root looks similar to our symbol for long division, but note that it does have this little tail to it. Also, you are going to need a calculator for this section. If you have a calculator that has 2 lines of text on it, you will hit the square root button first, then type the number. If you have a calculator that has only 1 line of text, meaning that your answer and your stuff that you're typing in appear on the same line, then you will need to type the number first, then hit the square root button. So before we get into Pythagorean Theorem, let's just make sure that we can find square roots on our calculator, or that we understand what we're looking at. So if you need to pause real fast, go grab your calculator so that we can go ahead and calculate these out together. So the first 3 that we're going to look at, A, B, and C, these are perfect squares, so we should be able to calculate square roots easily. So for square root of 36, I want to know what times itself equals 36. Our answer should be 6. 6 times 6 equals 36. So the square root of 36 is equal to 6. For B, the square root of 25. What times itself equals 25? We should get 5. So the square root of 25 is 5. For C, the square root of 100, we can ask ourselves what times itself equals 100, and I get 10. 10 times 10 is equal to 100, so the square root of 100 is equal to 10. For the next 3, we will want to use a calculator. Because these are not perfect squares, we also want to make sure that we go ahead and pay attention to the instructions. It says round to the nearest thousandth. So remember that this is 3 decimal places. So on your calculator, go ahead and figure out square root of 35. I get 5.9160. Remember that we do want to go one more place after thousandth to figure out how this rounds. 0 tells me to round down, so this is going to be 5.916. All right, if we look at square root of 124, I get 11.135. There's my thousandths place. I want to go one more digit. Our next digit is 5. And now if I go ahead and round this tells me to round up. So we get 11.136. And for the last one, the square root of 40, I get 6.324. My next digit is a 5, which tells me to round up, so we get 6.325. All right, so that is square roots. So let's talk about how we're going to use these in terms of something called the Pythagorean Theorem. So the Pythagorean theorem is a formula for the relationship between the sides of a right triangle. We refer to the two shorter sides as legs, for instance here and here. These are the two that meet at the right angle. And we refer to the longest side as the hypotenuse. This is the side opposite the right angle. So our procedure for finding the missing length, we're going to plug in the given information into our formula, which is a squared plus b squared equals c squared. We want to isolate the variable term, and then we're going to take the square root of both sides. Now, some other formulas that you might see is a and b are known as the legs. So we can do leg squared plus leg squared equals hypotenuse squared. Or we can also use one of the formulas over here. Now, me personally, I prefer using a squared plus b squared equals c squared. It's a little simpler, and you don't have to memorize as many words or formulas. All right, so let's go ahead and jump in and see how this works. So for the first example, we have a right triangle. We have 3 and 4 as our sides. And notice that we are missing the hypotenuse. This is our c value. So in order to find the missing side, we're going to use our Pythagorean theorem. And we want to plug 3 and 4 in for a and b. So we get 3 squared plus 4 squared equals c squared. All right, if we go ahead and simplify, 3 squared is 9. 4 squared is 16. And if we add these two things together, we get 25. So notice here what we have is we want to know what squared equals 25. And that's the same thing as square root. So what we're going to do is take the square root of both sides of our equation. Squares and square roots cancel. So we get c equals 5. We want to include correct units, and because this is a length, it is going to be just regular units. So we get c equals 5 feet. Okay, let's try one more. On this one, we have a leg, which is 5 inches, and we have the hypotenuse, which is 13 inches. We are missing a leg. I'm going to call it A. You can call it either A or B. So if we plug into our formula, we get a squared plus 5 squared equals 13 squared. All right, if we simplify, we get a squared plus 25 equals 13 squared is 169. I want to isolate my variable, so I want to subtract 25 from both sides. And now we get a squared equals 144. So what squared equals 144? To get rid of our square, we take the square root. Our square and our square root cancel, leaving me with just a. And now what times itself equals 144? That's going to be 12. We include our correct units, so we get a is equal to 12 inches. Okay, so these are some basic ones, and on these ones you technically don't need a calculator. For the next slide, we will. So for this side, let's go ahead and see what we can do. For the first example, we have one leg is 7 centimeters, and the hypotenuse is 15 centimeters. So if we plug into our formula, I'm going to let 7 be B, and 15 is equal to C. So we get A squared plus 7 squared equals 15 squared. If we simplify, we get A squared plus 49 equals 15 squared is 225. We can now subtract 49 from both sides. We get A squared equals 176. And now we want to know what squared equals 176, so we're going to take the square root of both sides. And let's go ahead and round to the nearest thousandth. So I get 13.266. My next digit is a 4, which tells me to round down. So I get 13.266 centimeters. Okay, one more. For this one, we have 8 and 5 meet at a right angle. So these are both legs. So when we plug into our formula, we get 8 squared plus 5 squared equals C squared. All right, we go ahead and square both sides. We get 64 plus 25 equals C squared. If we go ahead and add this, we get 89 equals C squared. So I want to know what squared equals 89. So I'm going to take the square root, and I get 9.433. I'm going to go one more digit. I'm going to add the 9 so that I see that this rounds up. So this is going to be 9.434 equals C, and we include our millimeters. Okay, so that takes care of our Pythagorean theorem. Let's go ahead and look at some word problems that involve Pythagorean theorem. Okay, so the most common example of the application of Pythagorean theorem is a ladder leaning against a building. So for this one, we have a 25-foot ladder is leaning against a building and reaches a height of 20 feet. We want to know how far away from the building is the bottom of the ladder. So if we go ahead and label our drawing, we have a 25-foot ladder is leaning against a building and reaches a height of 20 feet, we want to know how far from the bottom of the building is the ladder. So this is kind of how we're going to set up our figure. Now we do know that this is a right triangle, and so we can go ahead and use Pythagorean Theorem. If we go ahead and plug in what we know, we have B is 20 and C is 25. So we get A squared plus 20 squared equals 25 squared. So if we go ahead and simplify, 20 squared is 400. 25 squared is 625. I want to get A squared by itself, so I'm going to subtract 400 from both sides. And we get A squared equals 225. We want to know what squared equals 225, so we're going to take the square root of both sides, and we get A equals 15 feet. Okay, one more. We want to know how long is a ladder if it is placed 8 feet from the building and reaches a height of 11 feet. So 8 feet from the building is going to be my distance on the bottom. It reaches a height of 11 feet. We want to know how long is the ladder. That's going to be my hypotenuse. That's going to be my C value. So if we plug into our formula, both of these are legs. We get 8 squared plus 11 squared equals C squared. Eight squared is 64. 11 squared is 121. If we add these two together, we get 185. And I want to know what squared equals 185, which is take the square root of both sides. We get 13.6014. And if we round to the nearest thousandth, we get 13.601. This rounds down. And we include our correct units, which is feet. All right, that takes care of Pythagorean Theorem and right triangles. We have one more video to finish up this module, which is going to be similar figures. So go ahead, take a quick break, and then I will see you back here shortly.